Hey everyone, so I want to quickly look today at a small problem that can happen with our particle simulations. Now I'm just carrying on from the previous simulation that we've been creating over the last few lessons, and I want to first look at what we had where, let me go into this. We had this kind of fountain effect, and we've looked at the variance and everything like that. But now I want to trim this right down. So let's go back to how we originally were. I want to create all of these, make them 0 again, and this one too. All right, and I might use inherited velocity. Let's see what that does. Okay, now that's going down because of this gravity. Let's turn off the gravity. Okay, now it's just filling the ball. What I think I also will do is put this down onto the ground plane. So I'm just turning off that transform there. Okay, and I want to actually get rid of the ground plane as well. So let's turn this off. Let's do that. All right, that's good. And now I've just got this sphere right in the center here. And it's creating points, but just around the surface. Okay, good. Now what I want to do is be able to make this just shoot these points across here. And the way I will look at that is I can add some velocity. So let's set initial velocity, and I'm probably gonna just make this 1 here. Let me see what direction that is gonna go. All right, there we go. Okay, now I want to look at this gravity. Now the gravity is a force, and I want to replicate that, and I can see that I've got this minus 9.8, basically minus 9.8 meters a second. So let us look at that, and I'm going to put that into here. Yeah, let's put that into here for now, and we will see that this is dropping. But there is one difference, and a way that I can demonstrate this probably a little bit better so you can see is if I put this into the right. Let me make that just 9. I don't want it to be minus. And if I go into my geometry spreadsheet, I can check this out. So I go into my pop object, click on geometry, and I've already selected that previously, but you can see here I have all my attributes, and there's a lot of them that are connected to the geometry part of this network. So I just want to have the velocity. I want to check that, and it's this v1 here, but let's make that easier. I can go into my attributes, search for it, just v. There we go. It's not called velocity, it's just called v. And I can see that my velocity is set to 9.8065 if I want to be pedantic about it. Now when I move this animation, I can see that it always stays at that velocity. It doesn't change, so the whole thing is moving in unison, right? Now if I go into my gravity, so I want to turn this off, I'm going to use inherited velocity because there is no inherited velocity, so things stay where they are. And I open my gravity, and I want to set up basically the same thing here. So I'm going to add this to there. Let's make that also positive, and I'm going to make this 0. Now why have I done that? Well, just to replicate exactly the same one as before. Now gravity, of course, always goes down, but in Houdini I can play around with this, and I can now make this force go in X. So let's do that, and I can see now that this is moving in almost the same way that the last one was. However, this is a force, and I don't know if you know your physics well enough, but forces are accelerations. They accelerate, right? So they get faster and faster over time. So if I go back, let's turn this off, and I go back to this one, and I put on my velocity, I remember what happened. It kind of goes all at the same speed because this velocity here never changes. Well, when let's put that back to here. When I put on my gravity, see if you can see the difference. Okay, you can see hopefully that it starts off slowly and gradually gets faster. There we go. Whoa. And I can see here, if I look at my velocity, it's increasing all the time. It's not there. Let me push this up to the top. All right. Now you can see it's getting faster and faster as that velocity increases. So how is that acceleration working? Well, if it's going 9.8 meters a second, 1 second from here will be around 25, I think. Yeah, that'd be 24 frames higher. And then I've got this 9.8. See, I've got exactly the same number that I put in here after 1 second. But if I go forward another second, now I can see I've got this 19.6133, and this is basically going to be double what this is, or thereabouts, right? So I can see that this every second is adding more and more to this velocity. It's getting faster and faster, and that's how forces work. Now in this particular example, it would have made more sense for me to use a pop force, but I didn't want to get into that just yet. I'm going to save that for another lesson, so I'm just using the gravity as the force here. Now as I go through this, I will notice that something strange starts to happen. It looks great there, and then if you look, I'm starting to get these little kind of balls that are appearing instead. Let me in fact make the birth rate a bit higher. So I'm going to make this to 4,000. Maybe you can see it better now. So let's go through this again. Where is it? It's coming. There we go. All right, and I can see that these balls are appearing instead of being how it is at the beginning, where it seems kind of more blended together. The reason for this is that each frame, it is creating a bunch of particles. And as the acceleration increases each frame, those particles are becoming more separated. So I need to find a way that I can blend all these together. Unfortunately, this is just the way of simulations. Let me try and get that kind of got stuck there a little bit. Now the way to do that is, if you remember from the previous lesson, I can just add some variance. So I've already got this in place. I'm going to set the velocity. I'm going to make this 0. Now I should have exactly the same thing as previously. And I want to add a variance, this time in X, because this is the direction it's going. Let's add a variance of 1 and see what happens. And there we go. Now it's looking a lot better. Okay, so it's now blended together. So if you get that problem, which you inevitably will, the solution at this point is to add some variance. There are other situations, other solutions to that, but I find at the moment anyway that this one is the most basic one to use, and you've already learned about variance, so it makes sense. So I hope that was useful, and you guys have a great day.